Hello students, welcome to Physics Pathshala. Let us start our physics class for class 11, chapter 3 is motion in plane. It is two-dimensional motion. That means in which two coordinate of the position of the object will vary during the motion. And each position during the motion will be represented by two coordinate, let it is x and y axis, and the origin is represented by O, is O 0 and 0. Then in this case, if any object will move and in its instant x coordinate as well as y coordinate will vary, then this type of motion will be termed as two-dimensional or motion in plane. If it is moving in a vertical plane, it is termed as projectile motion. Whereas if it will move in a horizontal plane and in each instant, on each instant, its motion will have change in its both x and y coordinates. This type of horizontal plane motion will be termed as uniform circular motion. Now projectile motion, it will be in vertical plane, that is plane that is perpendicular to ground. Each instant both x and y coordinate will vary. Let x is the axis parallel to ground and y is perpendicular to ground. In that case, during the motion, the force due to gravity F G will be acting on this object. This Fg will be mass of the object's time G, that is acceleration due to gravity. And this G is constant, value is 9.8 meter per second square. Whereas there is no any force or acceleration of the objects along the horizontal axis or x-axis. Now, if any object is thrown at an initial velocity u, which is at angle theta with x-axis, then u will have its components along x-axis and y-axis. Along x-axis, let's component is ux, and along y-axis it will be uy. Ux will be u times cos theta and uy will be u times sine theta. Now, as there is a acceleration in the vertical motion, that means uy will vary. That will cause acceleration, or due to this acceleration uy will vary. If now the initial velocity of this uy is uy, and after some time the velocity of this uy component will be py. Now, as we discuss, if any object is thrown at an initial velocity u, which is at an angle theta with the x-axis, then the u will have its x component ux and y component uy. Ux will be its component along horizontal direction or horizontal axis, or it will termed as horizontal component of this u, and uy will be the vertical component or component along vertical axis, that is vertical component of u, and ux is the horizontal component of u. Now, as there is a force in acting, that is Fg is mg times or weight of the object, and this force is due to gravity, and there is a acceleration, whereas this mass into acceleration, and this xg is acceleration due to gravity, which is constant, and its value is 9.8 meters per second square. It has been experimentally found. Now, as g is constant and acting during the motion, that means there is a change in velocity, or in vertical plane velocity will vary. Now the initial velocity is uy and final velocity will be uv. It will obey the law of kinematics of first law equation. Uv will be uy plus at. Here a is acceleration and g is due to gravity. In this case, a will be value, magnitude of a will be magnitude of g, whereas direction as the acceleration due to gravity is towards down, hence a will be minus g, or uy is equal to minus g and t. This is the kinematic equation for this motion. Uy. At its maximum height, the velocity will be, or Vy will be 0. Then such acceleration keeps on decreasing from certain value of uy to reach to its maximum value of 0 at the highest point. Now, if at this point Vy will be 0, or 0 is equal to uy minus g, and t is the time it will take to reach this maximum height, or tm can say. Now tm became uy by g. Uy is nothing but the velocity, initial velocity times sine theta by g. Is the time it will take to reach its highest points or highest position from ground. Now, from after attaining velocity 0, again velocity along this vertical plane or vertical component of the velocity will again increase during the motion, and now it will be, direction will be towards ground. To find out the total time period, now if you consider total time is t, the time period or time of flight. The time of flight will be time, duration during which the object will be in air. That means the time it will take once it is fired or it is thrown from its position, starting position, till it will reach the ground. This is time of flight. At the end of the motion, the net displacement along vertical plane will be 0. Now considering vertical motion, we had y is equal to ui plus t, and a is, if we are considering object is moving in vertical direction from ground, a is minus g, or ui is equal to minus gt. Another kinetic equation says s is equal to ut plus half a t square. Now applying this equation to our projectile motion, we will have s is the final total displacement, and u is the initial velocity y, and t is the total time of flight. Then come t plus half a is our minus g, and t is t, then becomes t square. Here the net displacement is 0. Now in that case, 0 becomes uyt minus g by 2 square, or g by 2 t square is equal to u times t. Now dividing t at each end, we get t is equal to 2u by g. Now this t became now t became 2u by g, or 2t, or t is equal to tn is equal to 2ui by g, or 2u sine theta by g. Another kinetic equation is d square is equal to u square. It's 2s. At the maximum height, Vy is 0, Vy square minus 2g. Here s become h, the vertical distance it covered during this motion. Now 0 becomes ui square minus 2gh, or h became ui square by 2g. And we know ui is equal to u sine theta, then or h became u square sine square theta Now I have three equations. One is due to equation for maximum height to Latin, which is equal to e square sine square theta by 2g. That is time of flight 2u sine theta by g. And another one is the maximum horizontal distance it will cover, and or it will touch the ground from its the point it is thrown, that the horizontal distance is equal to the horizontal component of the velocity, that is u cos theta times time of flight. Now it became u cos theta into t is our 2u sine theta by g, and this upper term became, our numerator became twice of u cos theta multiplied by u sine theta. That means u square sine 2 theta by g. This is the range of the flight.